Okay, so the last two topics we ran out of time over there to talk about were log plots. Before I talk about that, let me get a, like, how many of you have seen, or how many of you have graphed with logs? Only a handful of you. How many of you have not graphed with logs? A lot of them. Yeah, okay, so I am pretty sure that there's no log plot on the homework, but let me show you a little bit what it looks like. And I'm pretty sure none of you have done, has anyone done polar plotting? I'm really surprised if somebody did. Okay, good. So Han talks about it. If you keep this book around and you start getting into stuff in, after you transfer, where we're dealing with polar coordinates, this will become very valuable. Plotting, the visualization MATLAB offers you for polar coordinates will become valuable. We're not going to do that today. There's tons of other visualization stuff in there. Just dig around. Just familiarize yourself with what the capabilities are and know that you can come back to it later. That's the key, right? Come back to it later when you need it. So we'll talk about log plots and then 3D plots. So what is a log plot? So what you are used to is axes that are linear in nature, meaning at every tick, the increment is the same. So if these are my 4 ticks, my increments are 1, 2, 3, 4. I'm quite used to that, right? That's what you're used to. On this y-axis, I'm going to change this to a log, base 10. And what that means is every increment, every marker, I'm not going up by the same amount. I'm going up by an order of magnitude. In this case, the order of magnitude is 10. So I might start with 1 here, but this next tick is going to be 10. The next tick is going to be 100. And this next one is 1,000. So it may not seem that different, but think about it for a minute. What that means is between here and here, the difference in your numerical value, the difference in the magnitude of your value is 1. The difference between here and here is what? 900. And this is the same visual space as this. Does everyone see that? That's the logarithmic plot. Okay? You can do a log on either axis. You can do a log on both axes. It's your choice. It depends on what you're trying to visualize. Why do a log plot? Okay. One of the main reasons for doing a log plot is when you have a huge variance in the magnitude of the values you're trying to show. And you need to be able to show how it varies in the range when it's 1, as well as how it varies in the range when it's 1,000, when the variance seems to be proportional to the magnitude. Right? This is maybe doesn't make total intuitive sense, but just if you get to it in the future where you have a set of data where the range is really big, and you do it on this type of linear plot, it may not fit, or when you do get it to fit, you basically can't see any of the stuff that's happening in the small values or the really big values. And so to try to get to a place where it really, you really are seeing characteristics of your information that are important across the spectrum, you might go to a log plot. Okay. Any questions on this sort of this very, very big, quick introduction to what a log plot looks like? Okay, good. I'm glad I didn't pick anything for homework that was log related. So what are the commands? This is just for your reference for the future. If you want only one axis to be log and you want the other axis to be linear, the command is semilog. The command is semilog y. If you want log on your y, it's semilog x. If you want the x to be log. And then the parameters after that are the same as plot. Okay? 2 sets of data, 1 set of data, characteristics for font, and all the rest of the stuff is the same. If you want both axes to be log, anybody want to guess what it is? Oh, good guess, really good guess. No, it's log. Because that's what we call them. We call them a semi-log plot or a log log. Log is both. Okay. So I don't want to spend time on. I was going to show you an example, but I don't want to do that. Okay. So then 3D plotting. Okay. There's a ton of stuff in MATLAB that you can do in 3D visualization. I'm just going to show you this plot 3 command to start. And if time permits later on and it makes sense, we'll go and do meshes and surfaces and those kind of things. But let's just do plot. It is just like our regular plot, except it's called plot 3. And it works very similarly to our regular 2D plot, except now it's expecting 3 vectors. The 3 vectors represent the x value, the y value, and what do we often use for our third dimension? Z, exactly. X, Y, Z. Hold up. Again, not introducing, just for a moment. There's no matrices here. We're still just vectors, single dimensional vectors, if you will. Right? Single dimensional arrays of vectors. Okay? And same thing. You take the matching element and you combine them, and that becomes your x coordinate, your y coordinate, your z coordinate. Those are your things. This is people often called, visualization of this kind of data is often called a point cloud. How many of you have heard of LiDAR? LiDAR? Anybody? Anybody who's into like visualization, satellite visualization, LiDAR? LiDAR is like the data output you get from a LiDAR machine is typically a point cloud, and it's an array. It's three vectors, x, y, z. I did really go look for some nice LiDAR data, and I couldn't find anything that would work for us for today. I might try to find it for next week, and we can do some fun stuff with it. I will show you a quick example of 3D plotting. Okay, any questions on that so far? Okay. So let's do this. Let's do, somebody change my font. Can you guys see that? Is that big enough? Is that big enough? Okay. So let's just make sure everything's clear. Okay, so let's do x equals 4, 7, 8. Let's do y equals 9, 8, 12. And then I'm going to make a z equals 10, 3, 2. X, Y, Z. And what I'm going to plot, how many points am I going to plot given this set of data? 3 points, right? Oops. Voila. Hello. Oh, that did not look very interesting. Okay, so there we go. There. So you can, when you get a 3D plot in MATLAB, you can rotate it around. So you can kind of, you click, you grab it, you turn it, and you can see we have 3 dimensions here, right? We've got, this is probably X, this is probably Y, and that's Z. So you can see we have 3 points in space, and I can rotate this thing around to get different angles on it. Oh yeah, good suggestion. Yeah. Now, if it wasn't just these 3 random points, and we had something nice to visualize, it would look a little bit more interesting. And I was hoping to get that tonight, but I wasn't able to find a good set of data. Yeah. That's plot 3. I'm not going to show a semi-log example because I think it may not be so good. So if you have taken a look at the problems, there are 4 of them. Let me walk through them real quick, and you guys can tell me how you feel about them so far. Okay, we've done this population stuff before. You guys remember? Okay, so it's the same population thing again. And I'm asking you to visualize it, but I'm asking you to combine the visualization of the theoretical. The theoretical is that equation up there, right? Let me get my pointer. Asking you to combine the theoretical, which is that equation, with some additional real-world data that's been added. So this is real-world data. And just to be super clear, these are different population values, and the increments are the magnitude is in the thousands, and the increment is decades. So this first value is 1790. The next value is 1800, 1810, 1820, et cetera, all the way to 1950. Are we cool on that? Yeah. So all we're asking you to do here is to have on the same figure, on the same plot, both the theoretical value and the data plot. Okay? Okay, so then we get to the next question. And for those of you with the newer version of Han, these are in chapter 9, not chapter 7. We're showing an iterative relationship. What an iterative relationship is similar to some of the stuff we've already done. But if you think about, I have a value at this moment, in the next moment, my value is dependent on the value previously, right? So when we did all those financial calculations, we were basically doing iterative calculations, right? My next month's balance is based on my previous month. And the month after that is based on this month. And the month after that is based on this month. And this is describing that same type of relationship, but without months. There's no months and there's no money here. This is a mathematical relationship. You'll get some really cool visualizations out of it. So you see these subscripts, the k's, and the k+1s? Those are referring to, you can either think about it as the element in the vector or the time step in this process that we're talking about of your iteration. Right? So what this is always saying is the next value, the k+1, the next value is always dependent on this formula that's using the current value. Right? So the way I just articulated is k is my current value, k+1 is my next value. Okay, and that's true in every step. So I want to calculate this 100 times. I'm going to do 100 times over. If I want to do something 100 times over, what kind of construct can I use? For loop, exactly, right? Great. So you will probably use a for loop for this, okay? And you give you some really interesting information about some initial values to start with, as well as some values of R. So R is a coefficient here that can get you slightly different results. So here are some interesting values of R to try to see how this comes out. Now, I do want to just show you what this might look like really quick. I'm missing a parentheses. I need to fix that for you. This is another one. This is a fractal. If you've ever seen fractals before, they're really cool. They look really cool in MATLAB. Again, this is an iterative relationship. So the next moment's data, the next step's data is equal to this current step's data. Okay? And to be super clear, we're not dealing with time anymore. We're really just dealing with this progression of this equation. In the first case. And that k+1 is like just a subscript. Yeah, that k+1. I wish Canvas's equations looked a little clearer, because that k, I totally agree, that k is too high. This k+1 is a subscript. That k is a subscript. That k is a subscript. Which is likely when we're thinking about positions within a vector. Yes. Okay. Yes. Yes. Those should be subscripts too, yeah. So I'll fix that in a moment. This and the parentheses, I'll get there. And these are the x sub 0 and y sub 0, they refer to effectively your starting values. The one thing you have to be careful about here is, does MATLAB start at x0? X index 0. No, MATLAB starts at 1, right? So these zeros are reflect sort of the mathematical convention. We start at naught or x0 or x0 for the start. But you will have to sort of transition that into the MATLAB world, which is the first index in any vector in MATLAB is 1. Now, both of these problems do not specify the number of iterations. And so part of that is for you to sort of figure out what number of iterations gets you to something cool. Okay? Play with that. I definitely think, you know, it's a computer that's doing it for you. Exercise some larger numbers. Don't necessarily go to 10 zillion. What did you try that one time? You don't have to go to gigantuan numbers, but definitely go beyond 100,000. Yeah. And then this last one, it's really basically that last homework that we did with the data, input the data, and visualize it in a different way. I'm asking for subplots here. Okay? Now, I do want to show what one of these iterative plots look like. Dimitri had asked that why don't we do some more examples in class. I think it's a reasonable request. I have to apologize because the example I have is not very interesting, or we'll see how interesting it comes out. But so I decided let's do a iterative relationship with 3 dimensions, okay? And so I've tried to replicate that same sort of I+1. I use I here instead of K, it doesn't matter, right? These are still subscripts. So I've got 3, and the reason I got 3 is because I wanted to do it in 3 dimensions, yeah? So I've got X, Y, and Z, and my relationships are just based on the previous values, and there's just a coefficient here. We could tweak those coefficients and see if we get something more interesting. And I didn't want to add an exponential in here. We can do that too if somebody really, really wants. Okay, so there should be good comments here. I'm doing this in the interest of time to get you guys going here, huh? Okay, so let's do x co. What's my x coefficient up there? 0.3. What's my y coefficient? -1.4. And what's my 1.1? Everybody okay over there? Open break? Yeah, I can do that. Is that big enough, or do we want more?
A little bigger.
Let's try this. How about that? I made it bold. Okay, let me. I guess it wasn't bold enough. I thought the bold might help us with that. Okay, how about that?
Yeah, there you go.
All right. Okay, so here I just decided to basically make these coefficients parameters so I can tweak with them a little bit later. Okay, so and then I'm going to define max iter, let's say 100. Or what variable am I using up there? I? Yeah. Now we are going to run into a little bit of the same problem that we saw in the homework for today, which is what number do we want to start on? What iteration do we want to start on? The other thing is that we didn't specify initial values. So for these problems in the homework, you're going to have to work on this too. You need to seed these with initial values. Where are you starting? Because this doesn't tell you anything about where you're starting. Right? So let's do that here. Now, I want to put something in that first I location. How do I reference that in vector notation? How do I tell MATLAB I want to put something in the first location of X? Without a parentheses or with the parentheses? Okay, good. So that says to MATLAB, hey, I'm doing this assignment, right? Remember my equals is my assignment operator. I'm putting some data into the vector X. I'm going to put it into index location 1. Right, okay with that? Yeah. I don't know what values to use, guys. I just whipped this problem up, so let's just try 5. I need to do this for all of my X, Y, and Z. Yeah, thank you, thank you. Let's try 10, and let's do. Which one's my negative one? Okay. Everybody okay with what I got so far? Any questions on what we got?
Are you using that by X 0.3 times X?
Yeah, exactly. That's what I will do inside of the for loop. So far, all I've got is setup. Like what I've got here is defining the coefficients. Those are these values, right? Okay. Then I've got this initial setup. So I'm saying, hey, MATLAB, I got some vectors coming. Hey, MATLAB, I'm going to assign these to location 1. I actually don't know if I need these. I think MATLAB is pretty loosey-goosey. We'll let me try without this.
So the X1, Y1, Z1 are initial values.
Correct. Yeah. So if I, here it's all parameterized. Here's i's and i's plus 1s.
Yeah.
But in order for this to make any sense, there has to be an x1. Yeah. And this problem, as presented here, doesn't have it. So I just made up some values. I think in the homework there are some prescribed initial values for some of it. And then this specifies how many iterations I'm going to do. And so we're starting with 100 and see what it looks like.
So you were saying there's a potential that if you just did x1 equals 5, you're creating a vector that way anyways?
Yeah.
Okay. Yeah. And like an open-ended vector.
Or, well, MATLAB doesn't have that concept, right?
Yeah.
Did I already have X defined? I did. Sorry. I'm like, hey, why did that do that? Yeah. So MATLAB doesn't need. And so this is, this like commentary, but this is one really big difference between, say, MATLAB and most other programming languages. MATLAB will let me not have these here. Most other programming languages will insist on you setting this up. Here it causes no problems. Okay, So what you guys, can you guys help me out? What does this look like down here in my for loop? What do you guys think that looks like?
X coefficient times. X
Okay. Good start.
equals X.
Do I put the equals on that side or on this side?
Left.
Left side. Okay. So like that?
Yeah. X
Okay.
equals
Okay. Really close. This is super, super close.
We
What else do I need on here?
I.
Yeah, I need to specify. Otherwise, what I'm going to do is X is going to, if I do this, X turns into a scalar here. Or X is, depending on what the state of X is, okay? Let's say X is a vector. It's just going to do the entire vector times the coefficient and stick it into the same vector. I'm actually hoping to do this iterative index by index thing, right? I don't want to operate on the whole vector at once, assuming I have it. And here I just have a scalar.
So that was I plus 1.
Yeah, so let's do that. I plus 1. And here's where things can get tricky. Like you could do, like the example we saw with Miranda, we could start at 2 and do I negative 1, right? And let's see, what would that look like? So that would look a little bit more like this. But you see, like mathematically, those two are effectively the same. Yeah? It does depend on where I start. So if I wanted to use the second one, what would my index vector have to start at? 2, the opposite direction, right? Because I'm going to do, if I do 1 minus 1, I get index 0, which doesn't mean anything about that.
Oh, I thought if you change up top, you change X 0.
Okay, let's see. Let me comment this out. If this was the code, I would have to do it like this.
But in this is the last statement, I would call it say whatever we want to start.
I don't think that will allow it.
Oh.
I believe index 0 on MATLAB is undefined. Let's just check that later. Sorry, guys. Okay. All right. So what else do we need in our code here? Get this thing lift up and you get you guys started on your homework. I'm going to stick with that one. So I'm going to comment this out and do that. Okay. What else do I need here?
You did the same thing for the Y and Z dimension.
Exactly. Everybody see that, right? Okay, am I done? And I need my end, yeah. How many are annoyed by Octave always putting n before? Okay, and then what I want to do is I want to plot this in 3 dimensions. So what command can I use for that? Plot 3. And what do I need to get plot 3? All right, let's see what this looks like, shall we? I'm very curious because I have no idea what this is going to look like. What do we call it? Oop, I didn't do semicolons, huh? Not a good idea. There it is. Not that interesting. It was not interesting at all. Huh. Okay.
You need like a square in there or something.
I know. I was trying to stay constrained. All right. Who wants to add us? Where should we add our? Actually, let's do this one. Let's do one of those. Let's do that real quick. Oops. Are we doing some math now? What's going on? Oh, x smacks to 0, y smacks to 0, and z. Oh, because I got fractions in here, so everything is approaching 0. You guys see that?
Yeah.
Okay, everything is basically approaching 0 because everything I'm doing. So let's change these. Oh, except for z. Z just goes through this.
Because it's 1.1.
Yeah. All right, let's do this. 2.3.
So it's growing really small.
Really small. I love it. Love it. Limits are too large. Right. See, this is, Dimitri, I'm sorry. This is what happens when I don't come prepared with the example. Huh? It looks like a turd. This is a learning exercise. It's all good. There. That does not look that interesting, but. Oh, interesting. From this perspective, you see some curvature. That's pretty cool.
Mm-hmm.
Okay, so let's do one last thing just for fun. Let's throw a square in there. What is that square?
I don't know.
All right. So clearly, this math is not very
Cube something. You maybe think that it's straighter and straighter. Like cubic actually has a bend. Has curvature.
All right. This is the last one.
It
okay,
should.
guys?
Nothing. There it is.
Can you snap the certain? Do you think that grid?
Yes. Let me show you that. Right, so I believe the command is view. So it basically says it sets your azimuth and elevation. And actually, that's one. I think Cartesian coordinates would be better. So it says here where you're viewing from. Basically, that's.
Azimuth is the angle.
Yeah. Yeah. I remember using this before. You have to think about it a little bit more.
That's why I didn't know there was a tool within the plot, speaker plot that will let you.
Oh, other than spinning it around?
Yeah.
I mean, there's the home, and then there's this moving it around.
Yeah.
Your question is, can you enter a location?
Well, no, I meant
Like
like
snap the x-axis.
yeah, snap to Y, it's like X, Y.
Oh, yeah. I think there might be. Yeah, I don't know. We'll play with that later. Okay, how do you guys feel about this so far? Okay, but if that changes in the next day, 2, 3, you guys are going to yell and say something, right? Promise? Okay, good. And if it's going well, you'll tell me something too, okay?
Positive feedback.
Not necessarily positive, but it's just like things are going okay. All right. So I don't know if you noticed, but I did pull off the accelerator a little bit.
This is a lot of code we've already done
Do
before.
you notice that? No?
I know.
That's awesome. Okay, get started so I can help you guys if you have questions. So you got a good solid hour. If you have an exam to study for tomorrow, I totally understand. You can go. No worries. Okay. I realized that I made your weeks challenging, but it wasn't just my fault. The other instructors.
It was the other instructor's fault.
Bye, Alex.